Hey guys, previously we discussed various advanced features and utilities of Workflow Manager. Now we'll talk about various advanced aspects of Workflow Manager. Now we'll talk about performance optimization, configuring partitioning and various types of partitions, and pushdown optimization. We're at the last video. At this stage, you must be pretty clear with all the components and features of Informatica tool. As with any other technology related to data, we need to also. It's necessary to follow the best practices to achieve the best performance out of your code. Similar to SQL tuning, which is done to enhance performance of SQL query, we do performance tuning on Informatica. If you follow the best practices of Informatica, your code will be automatically tuned. There are many best practices, many of which we already discussed in previous videos. We'll be talking about those best practices under this video. Also understand how to use those practices to achieve the best performance. Performance optimization. In this video, we'll discuss how to understand the performance tuning of Informatica, understand bottleneck. The regular process is to first find out the bottlenecks, then eliminate those to enhance the performance. When we talk about performance tuning, you need to find out the issues in your code, called bottleneck. We'll discuss various components which need to be tuned to enhance the process, eliminating bottlenecks, and identifying the bottlenecks at various components. Bottlenecks. As mentioned, we can have bottlenecks at various stages of Informatica PowerCenter code. Don't be in a rush to find all the bottlenecks together and eliminate them. Try to find the first one, resolve it, and jump to another. Finding target bottleneck. Always consider checking the bottlenecks at target side first. There can be various reasons of bottlenecks at target. First, we need to learn to find the target. Using thread statistics. These are a part of the session log. When you run the workflow, the session log also generates the thread statistics, which can provide you information about the bottlenecks present in the source, target, or transformations. Thread statistics gives information about the total runtime, idle time, and busy percentage of source, target, and transformations. Thread statistics consist of reader thread, writer thread, and transformation thread. Reader gives information related to the total runtime, idle time, and busy percentage of the sources in the mapping. Writer gives information about the total runtime, idle time, and busy percentage of targets in the mapping. Similarly, transformation gives information related to transformations in the mapping, as indicated below in the sample thread statistics. As seen in the statistics, writer is busy for 99% compared to reader and transformation. We could say in this case, the target is bottleneck. Similar to this, you can identify if other cases source or transformation have bottlenecks. Here's another way to identify a bottleneck. Configuring sample target load. It's a simple understanding that loading the data into target table will take more time as compared to loading the data in target file. Consider you're loading the data into a target table in your mapping. Configure a sample run and try to load the same data into a test target file. Check the difference in the runtime of both the processes. If there's a significant difference, you can easily say that database target table have a bottleneck. Eliminating target bottleneck. There are various ways which you can optimize the target loading. Minimize target table deadlocks. There could be a scenario when Informatica is trying to load the data into a table, which is already being used by another system. When Informatica encounters the deadlock, it hampers the processing by slowing the loading process. To avoid this, make sure the target table is not used by another process at the same time. Drop indexes and constraints. Loading the data into a table takes more time because there are multiple indexes and constraints created on the table. Each time a new record is loaded to the table, it's first checked for indexes and constraints before it gets loaded. This hampers the performance. To avoid this, you can use a pre-SQL and post-SQL command in the session task. Using pre-SQL commands can remove the indexes, and using post-SQL can apply the indexes. When you define pre-SQL and post-SQL, Informatica applies those commands before and after the data in the loaded table. Removing the indexes and constraints as described above is not always recommended, but definitely improves the performance. You can opt for this option if the data you're loading in the table is not very critical. Increasing checkpoint interval. When you run the workflow, integration service keeps on creating checkpoints at predefined interval. The checkpoints are used for recovery purpose. Reducing the checkpoint interval will help enhance the performance by storing less checkpoints and storing less data related to the checkpoint. If you reduce the checkpoint interval, even though the performance will increase, it will also hamper the recovery time if the system fails with some error. Using external loader. IPC supports usage of multiple external loaders like IBM DB2, Oracle, Teradata, and Sybase IQ. They can help in faster loading into the target table. To add the external loader, open Workflow Manager, click Connection, External Loader, as seen here. In the next screen, select the loader based on your requirement. This will help enhance the performance by loading the data at a faster pace in the target. Increasing network packet size. Every table has a capacity, referred to as network packet size, with which it can accept the data. If you increase the packet size, the table can accept greater volume of data. These properties can be enhanced by a database admin. You may want to consult with your database admin team. Using bulk load. By configuring the session properties to use the bulk load, your performance can significantly enhance. When you use bulk loading, the database logs are not created, in turn, enhances the performance. If you disable the database log, the recovery cannot be done, as there is no log of the events on the database. As you may notice, performance can be achieved by compromising on some other factors. You need to decide and make a fine balance between all the factors. These were the various ways in which you could bind and eliminate the target bottleneck. Let's talk about source bottleneck. Finding source bottleneck. This can also be impacted at the source side. Various factors can hamper the performance at source side, as we discussed at the target side. Using thread statistics. As discussed earlier under target, use thread statistics to find the source bottleneck. You can refer that section to use the thread statistics. Test mapping. Using a pass-through mapping can help you identify if the bottleneck is at the source side. Configure a test mapping to have only source, source qualifier, and target. Consider you have a mapping with one source, one target, and 10 transformations. The time taken to process the data through the mapping is 60 seconds. This means combining the source, target, and transformations is taking 60 seconds. Create another mapping by eliminating all the transformations and run the process and check the time. Suppose the time taken to complete the process is 50 seconds. Compared to the combined time of target and transformation, which is 10 seconds, 50 is relatively high that the source has to execute. This indicates we have a source bottleneck. Using filter transformation. You can use a filter transformation to check if the source is having a bottleneck. Put one in front of the source qualifier and set the condition to false. Don't allow any record to pass through the filter ahead in the mapping. Using this method, you can compare the runtime of the process with and without the filter condition. This way, you can identify if the source has a bottleneck. Checking database query. This is another simple method to find the source bottleneck if you're extracting the data from the table. When you use source qualifier to read the data from a database table, integration service writes a query to extract the data. Copy the query and run the same query at the database level in SQL Developer or a similar tool. Compare the time taken by the query to execute at both the places. This could give you an idea if the source has a bottleneck. Eliminating source bottleneck. There are various ways which you can optimize the source. They're discussed as followed. Increase network packet size. As discussed under eliminating target bottleneck, increasing network packet size of the table will allow greater volume of the data to pass the network at the particular instance. These can be enhanced by a database admin, so I would consult your database admin to increase the network packet size. Optimizing database query. When you read the data from a database table, integration service generates a query to extract the data from the table. You can fine-tune the query to extract only the required data. If you extract all the data, then add filter or other transformations, it'll hamper the performance. You can tune the query to extract only the required data. This will save time and help in performance enhancement. This is called SQL override. These were ways in which you could find and eliminate the source bottleneck. Let's talk about mapping and transformation bottleneck. Finding mapping bottleneck. If you don't have a source or target bottleneck, you may have mapping or transformation bottleneck. Thread statistics. As discussed under finding target bottleneck, use thread statistics to find the transformation bottleneck. Filter transformation. You can use that to check if the transformation is the mapping. If the transformation mapping is having a bottleneck, put a filter transformation before the target and set the condition to false, meaning do not allow any record to pass to the target. Using this method, you can compare the runtime of the process with and without the filter condition. You can identify if the transformations have a bottleneck. Single pass-through mapping. Consider you have a mapping with a source, source qualifier, few transformations, and a target. Execute the process and check the runtime. In the next run, remove all the transformations, and just have the source, source qualifier, and target. Execute the process and check the runtime. If runtime is having a considerable difference, this indicates the transformation in your mapping is taking more time compared to the source and target. Eliminate mapping bottleneck. There are various ways which you can optimize the transformations and mapping. Single pass mapping. Let's say you have multiple targets to load from the same source. In such a scenario, avoid creating multiple mappings. You could save significant time by loading the multiple targets in the same mapping. Use a single source and pass the data to different pipelines, then to multiple targets. This way, you could save the time of reading the same data multiple times in multiple mappings. Avoid data type conversions. Avoid changing the data types across the transformation in the mapping. When you change the data type, integration service takes time for processing. It's always recommended you should not change the data type wherever you're not required. Uncheck unnecessary ports. Passing unnecessary data through the mapping will hamper the performance. It's recommended if you do not need certain data, disable the output port of the column so you don't pass the data. Processing numeric data. Integration service processes numeric data faster compared to other data. Try to process as much numeric data as you can. Operators instead of a function. Integration service processes operators faster compared to functions. Consider using a pipe in place of concat functions to concatenate the data. Use decode in place of multiple IIF. If your logic contains multiple IIF functions, replace them using decode. Decode is faster to multiple IIF. Tracing level. Tracing level defines how much detailed information you wish to write to the session log. When you run the process, integration service writes the info about the run in the session log. Setting proper tracing level will help improve the performance. Use variable ports. If you're performing the same operation multiple times in a transformation, consider calculating the value in a variable port and use the port value multiple times in the transformation. Suppose you need to convert first name and last name in uppercase, then concatenate them. And also, you need to cut part of the data. In place of using upper function every time, use the variable port to convert data in uppercase, and use the variable port to perform other operations. That way, you save time in performing the same operation multiple times. Optimize filter transformation. You can use that as early as possible in the mapping to avoid processing unnecessary data. If you filter unwanted records early in the mapping, you can enhance the performance. Similarly, use router transformation in place of multiple filter transformations. That'll help save you time. Optimize aggregator transformation. Always pass sorted data to the aggregator in order to enhance the performance. When you pass the sorted data, the integration service needs to save less data in the cache, which helps enhance the performance. You can also improve the performance of aggregator transformation by doing a group by numeric columns. For example, consider grouping the data on department ID in place of location. It's only possible to do per your business requirement. Use incremental aggregation whenever possible in the session properties to enhance the performance. If you use incremental aggregation, you improve your performance, since aggregator now needs to calculate lesser records. Optimize joiner transformation. It's recommended to assign the table with lesser number of records as master. While using joiner, the table with lesser number of duplicates should be used as a master table. We also recommend to perform join in source qualifier using SQL override. Performing joins on the database is sometimes faster compared to performing in Informatica. Passing the sorted data to joiner transformation enhances the performance, as this utilizes less disk space compared to unsorted data. Optimize lookup transformation. Lookups are one of the complex transformations in IPC. Optimizing lookup will significantly help improve the performance. When you use lookup in the mapping, use concurrent cache. When you use concurrent cache, integration service caches the lookup table data before it starts processing the data from the source. Otherwise, lookup performs cache on row-wise basis, which uses more time. So we recommend you enable caching when you use lookup. If your mapping contains multiple lookups, which look up on same lookup table, it's suggested you share the cache in order to avoid performing caching multiple times. You can reduce the processing time if you properly use lookup SQL override in lookup transformation. If you're using lookup to look up on database table, you can use lookup SQL override to reduce the amount of data you look up. This helps save the cache space. If you're using more than one lookup condition in lookup, it's recommended you place the conditions in the optimized order. For instance, place equal condition first, then less than, then greater than, less than or equal to, greater than or equal to, and finally, not equal to. This will enhance the performance. These were the various ways which you could find and eliminate the mapping and transformation bottleneck. Now, here's session bottleneck. Eliminating session bottleneck. If you don't have source, target, or mapping bottlenecks, you could check session properties to check for bottlenecks. Optimize commit interval. Commit interval is the number of records after which integration service commits the data into target. Selecting appropriate commit interval will help enhance the performance. If you select commit interval as a low value, it'll make integration service commit data more number of times, which will hamper the performance. Buffer memory. When you run the workflow, integration service needs to allocate blocks of memory to hold the data at various stages of processing, including cache if required. Make sure you have sufficient buffer memory available, or else integration service fails the process because of the lack of memory. Performance data. Session properties allow you to store the performance-related details to repository. If you select to save the performance details, integration service writes the log to the repository. This will consume the processing time. Make sure you're not checking the option if you do not require to save the performance details. Eliminating system bottleneck. Last step in enhancing the performance you could try is find the bottlenecks in the system. Eliminating system bottleneck may not be in your control. You could contact your admin team for improving the system capabilities to enhance the performance. You can add multiple CPUs to make the process run faster, or make the session run in parallel. Check with the admin team if the network is working properly at the optimized speed to confirm if the processing is optimized. You can also contact them to add extra memory if the buffer memory or cache memory is not sufficient. Adding extra space may save the processing time if your cache memory requirements are more. Using the above-mentioned performance rules can make your process optimized. After taking care of all these rules, if you feel your system is not fully utilized, you can make use of partitioning.